Hello, this is a video on z-scores, which is going to further our knowledge of stats and the normal distribution, the relationship to standard deviation, and by understanding z-scores, we'll be able to answer more specific questions regarding standard deviation and percentages, as well as work into a few new types of questions as well. I'll start with an example. 1,000 students took a math test. The average was 70 and the standard deviation was 10%. How many students did you beat if your test score was 80%? So what this is essentially asking is, your test score was 80%, so if we fill in our chart, the average was 70, and the standard deviation was 10, so we'll have 80 here, 90, 100, and the standard deviation is going down, follow the same pattern, 70, 60, 50, and 40. So again, the average is always going to be at the center of our bell curve, the mean or the average, and then the standard deviation will be the steps to these lines across. If we scored 80, that means we scored right here. This was our score. How many students did we beat? That's going to be everybody in this region. So all these people in the green region would be the people who scored worse than us on the test. So if we knew how big this green region was, that's going to be our answer. Because the interesting thing about this normal curve is the size of the segments is representative to how many people are in it. If we remember back to last day, this segment right here had 34.1% of people in it. And so if we actually calculated the areas here, this light shaded area right here is going to be 34.1% of the area. So how big is this region? Well, we know that this section is 34.1%. We could go through and add up all of these pieces, but the good news is if we know that this was the average, everything over here is going to be the other 50%. So altogether, if we got 80% on this test, 50 plus 34.1, we are going to beat 50 plus, that's 84.1% of people. All right, this is just from last day. This is a question, but it's a good introduction because the next part we want to look at is, what if we scored 85% on this test? So again, same test, same results. Oh, that's not 80, that's not 95, that's 90, 100, 60, 50, 40. So now we scored 85 on the test, so we definitely did better. But where we fall is right here. And now we need to know this region. All right, let me fill it in. So this is where we run into issues with the analysis that we were doing last day, is that now that we have a result that is not an exact number, it's not falling on one of our standard deviation lines, we're not sure how much this is. We know how big this piece is. We know how big this whole piece is, but we're not sure how big this little green wedge right here is. How big is this green wedge is the question this brings up, and this is the question that z-scores can help us answer. How we're going to do that is by determining what our z-score is essentially asking where are we at in terms of standard deviations relative to the average. When we think of 80, up here, we had beaten the average by exactly 1 standard deviation. For this question, if we get rid of some of these black lines here, oops, we have beaten the average by 1.5 standard deviations. So when we want to find a z-score, it's just a measure of how many standard deviations you're different from the average. So if we look at the same test, the average was 70, the standard deviation was 10. So when we want to find a z-score, 70 was the average, so how many standard deviations away were we? 0. If we scored exactly average, our z-score is 0 because we have no difference from the average. If we scored 80, like in our first example, our z-score is going to be 1 because we are 1 standard deviation away from the average. Our second example here, 85, we are 1.5, so 1.5 standard deviations away. Our z-score is going to be 1.5. If we score less than the average, so 50 is 20 less than the average, which is 2 standard deviations, that's going to be a -2. And finally, 72.5, this is going to be 2.5 more. So the actual calculation, if we had 72.5 was our score, we want to compare it to the average. So we scored 2.5 more, 2.5% more. And if we compare it to our standard deviation, it results in a 0.25. So 72.5 is less than 1 standard deviation more than the average, and it ends up being a quarter standard deviation more than the average. And this is what that formula looks like. So your z-score, which we've just done a bunch of times in our head, is your score, or your observed value, subtracted from the average. So you compare it to the average. So if you did better than the average, you'll subtract it and get a positive number. If you did worse, you'll subtract and get a negative number. Think of when we did for our z-score of 50, it was 50 minus 70. And then we want to, how big is this piece compared to the standard deviation? So this was the calculation for when we had 50. 50 minus 70 is minus 20. Divided by 10 is -2. So we were 2 standard deviations less than the average when our score was 50. When we have our z-score, we can then use it to calculate the area. So this big colored in piece, there's tables and calculators that we're going to use for this. When we know the z-score, we can now find exactly the size of this big region. Yesterday we were adding up segments when we knew the exact lines. Now with the z-score, we can take any score we want compared to the average and find exactly the percentage of people that we're going to beat. So let's look at that in an example. The average length of a fish in good luck is normally distributed with a mean of 40 and a standard deviation of 12. What is the probability of catching a fish shorter than 49 centimeters? So we'll start, just like we did before, filling in these two pieces to fill up our chart. The average is 40, and our standard deviation is 12. So this is going to be 52, 64, 76, and going down, this will be 28, 16, and 4. Okay, so average in the middle, plus 12, plus 12, plus 12, minus 12, minus 12, minus 12. This is our chart. Now we would like to figure out 49 centimeters. Where does that sit? 49 centimeters is right about here. So we want to find the probability of catching a fish that is shorter than 49 centimeters. Fish that are shorter than 49 centimeters are on this side. So we need to find how many fish are in this area. All right. So take note, this isn't asking how many fish are shorter than it. It's saying what is the probability of catching a fish that is shorter. The thing that we can do with z-scores is, if we're adding one new item to the sample, so we're just going to catch a fish at random, the fish could be anywhere in the sample. It will follow the same pattern as the rest. So if we take one fish at random, the probability is going to be equal to the number of fish smaller than it. So asking about the probability of the next fish is same as asking if we did catch a fish that was 49, asking how many of the fish are smaller than it. So what is the probability of catching a fish that is shorter than 49? The first thing we want to do is calculate our z-score. And so our z-score is going to be how many more standard deviations above average? In this case, we are above average. We're less than 1 here, so we expect to get a z-score of something in between 0.5 and 1, because we are almost to 52 but not quite there. The formula was your observed value minus the average, we're using mu here, divided by the standard deviation. So 49 is the fish we're concerned about, the average is 40, and our standard deviation is 12. So that means we're going to end up with 9 divided by 12, which is 0.75. So our z-score in this case is 0.75. What does that mean for a probability? What we are going to use first is a calculator. Oh, this one right here. So calculator.net has a z-score calculator. We can even use it for our first calculation. So we had 49, 40, and 12. If we wanted to double check our work, our z-score is 75. And here it gives us the answer straight away. This shows us that we have the area left, 0.77337. So we'll write that down first. 0.77337. It just gives us the answer straight away. So the probability of our fish being less than 49 is 0.77337. What does that translate to? Well, a probability of about 77%. So what was the probability of catching a fish shorter than 49? About 77%. Okay, the last thing I want to talk about is often you'll be given these tables to calculate what your z-score is instead of using the calculator. And if you have to use the table is read in a first confusing way, but once we see it, it'll make sense. So our z-score was 75 or 0.75. Where is that on this chart? Well, draw. Our first digit is we are less than 1 in between 0. We are at 0.75. This whole chart is all the numbers for 0.7. 0.7, and our second digit was 0.5. So you can see here that we first read our first digit here to find our row, and then our second digit determines our column. And we can see here that this was the number that we used. So for reading the table, you use the 2 digits only. You put in the first digit, 1, 1.1, 1.2, 1.3, and if, for example, you had a z-score of, let's say, for example, 2.43. For a z-score of 2.43, we would scroll down to 2.4 and then over to 0.3. And this would be the result for 2.43 because we're at 2. Oh, no, that's not it. It's this one. Because we're over to from 2.4 and down from 0.3. And so that would be the probability of something being less than a z-score of 2.43.